So the next speaker is going to be Karl Zelik, and he's a professor at Vanderbilt. He holds one of the inaugural agility grants within WuXi Performance, and he's an expert on wearable devices. So please join me in welcoming Karl.
I'll just say up front, when the first talk of the day has an AI-controlled avatar that's dancing on water, you know it's going to be a good day. You also don't want to be the next speaker up, so I will not be thanking the conference organizers. Teasing, of course. Okay, I'm excited to chat today about the intersection of two emerging technologies, wearable assist devices and digital twins. A couple of disclosures up front. I wear a few different hats. I'm an engineering professor at Vanderbilt University. I'm also on the board of a nonprofit called the American Bionics Project that's trying to get more disability tech out of the lab and into society. And I'm the co-founder and chief scientist of a workforce wearable tech company called HeroWear. And all the pictures you see on the screen are examples of wearable assist devices. That's the first emerging technology, whether it's prostheses or exoskeletons, bionics. They cross all these different use cases from clinical to occupational to recreational realms. And these are devices that physically support or assist human movement. Relatedly, the project I'm working on as a part of the Alliance is an ankle exosuit, meant to be a lightweight ankle assist device that offloads the Achilles tendon with applications for helping to accelerate recovery, potentially to reduce injury risks or maybe even increase physical performance. The second technology and the focus of this session is digital twins. So as Karen nicely summarized, these are real-time digital models of physical systems, including the human body. So collecting this data and using it to drive deeper insights that can help direct interventions. One of the things I love about being a part of this alliance is this kind of moonshot thinking. I mean, you look around the room, all the interdisciplinary expertise that's here, and thinking about what's the intersection, what's the combination of some of these different emerging technologies. And so that's going to be the focus of kind of the talk today is how are these related and what are some of the opportunities? It's 2023, so the first thing I did to try to understand what this intersection was ask ChatGPT. Turns out it was not very helpful. It started spewing some nonsense. I tried to provide some creative or constructive feedback. It was having none of my sass. And things kind of devolved from there. So next I asked Scott GPT, aka Scott Delp. And he was super helpful. He also started spewing information, but it was cogent and helpful and useful, great associations. So first takeaway from this talk is ask Scott, not ChatGPT. I also talked to other people and I reflected on my own experiences. I've been doing R&D on wearable assistive technologies, wearable sensors, and biomechanics for the past 15 years, and tried to read up on, especially the last 5 years, what some of the intersections of these two emerging techs. And what I came away with at a high level was, first and foremost, these are two distinctly different technologies, but they're complementary. And there's the potential to have some combinations of these that are more than the sum of their parts. So just to give you a quick kind of overview of what's the state of the art with combining wearable assist devices and digital twins, it's mostly in the realm right now of proof of concept and frameworks. This is a paper from 2022, an example where they had a robotic lower limb exoskeleton. One of the big challenges with exoskeletons is control. And what they're trying to do is create a digital twin that allows some offline optimization, as well as some adaptive feedback that can take real-time data from the device and feed that back to improve control. Another really interesting concept is remote therapy. So people go home, they need to keep rehabilitating. There's an opportunity for wearable assistive devices to help with that therapeutic rehabilitation process. But how does the clinical team interact with it? And how does that device get controlled such that it can optimally help accelerate rehabilitation? This is another concept where they're building out the framework. They're building out proof of concept for showing this is possible. And there's some interesting things you can do if you think of the digital twin as this hub and intersection between the medical practitioners and the patient. And you see this also in the workplace. Digital twins are being used to model entire systems, entire workflows. And within that, humans are one portion. And there are some individuals that may benefit from wearable assist devices like exoskeletons. So all of this is getting rolled up into digital twins, both at the human level, the device level, and at the system level. So this is kind of the state of the art, proof of concepts and frameworks. And I'm thankful to be in a room with a bunch of innovators and researchers and engineers because this is the type of group that helps bring about the underlying science and the development that's needed to bring this all together into the future. I wanted to take a few minutes and kind of do my best guess at where do I think things are headed? What do I see are some of the really compelling and interesting use cases at the intersection of these two technologies, and what are some of the barriers? One of the use cases is what I would call kind of supporting locally while optimizing globally. So this is a rendering of a future factory, a future workplace. And the idea is global optimization involves trying to optimize the production or make things more efficient. But at a local level, you have machines and you have humans that are doing work. And particularly in the case of humans, there are some that are under a lot of strain, and there are applications where wearable assist devices might make sense to integrate. Digital twins that can take into account the full system can help us optimize and identify how and where to help people and what type of assistance they would benefit from locally in order to drive better performance globally. You see the same thing in sports, especially in team sports. If you think about things like soccer or basketball, you have individuals that are potentially nicked up, that are maybe returning back from an injury or trying to stay in practice and in games despite musculoskeletal or other injuries that they're dealing with. So how can we optimally assist these individuals while helping them retain their cardiovascular fitness and helping them maintain their activity at practice and with their teammates in order to stay coordinated with them? Another big area for digital twins and wearable assist devices to come together is to accelerate recovery. For some individuals, this is after a stroke or after some type of injury or neurological disorder. How do you help accelerate them back to living their lives? Wearable assistive devices might be part of it, but what type of assistance should we give? How do we wean them off the assistance if we're trying to get them back to a different steady state? And the same with work. We're already starting to see exoskeletons being used and explored as return to work tools. People are coming back from injuries. Again, the digital twin can help us understand what's the optimal way to provide assistance and how do we reacclimate these individuals to their jobs. And of course, the same with return to play. So for athletes, runners, for instance, having an Achilles injury, how do you provide the care and treatment that allows them to start loading their musculoskeletal system, because they need that in order to heal, and they need the activity at the whole body level in order to maintain their fitness, but how do you do so in a way that gets them back safely to their activity? So the big takeaway here is just I see a lot of unique opportunities under these two broad umbrellas where we can support individuals across different aspects of life through the intersection of wearable assist devices and digital twins. But what are some of the key barriers, right? It's not all gravy. There's a lot of challenges. And again, I'm thankful to be in a room with you all because it's going to take a group effort to tackle these. I pulled out a couple of key challenges that I see. This is not a comprehensive list. On the wearable device side, one of the big challenges I see is wearability, creating devices that are lightweight enough, not too bulky, comfortable enough, physically and thermally that people will be willing to wear them for the durations of time they need. Control is also a big challenge with devices. How do we make sure we have reliable control across different activities? On the digital twin side, how do we collect the real-time data and assure that data is clean and reliable in order to make decisions from? And then ultimately, how do we get to the point where we have actionable insights or decisions that can be applied to interventions? And where the Human Performance Alliance comes in is there are different groups from across these institutions, different researchers working on different aspects of these problems. And I think this is what excites me. This is what's fun being here. This is why I look forward to the virtual calls, is hearing what people are up to. And again, this is not a comprehensive list, but just a few of the different organizations working on different aspects of these difficult problems that we need to tackle together in order to bring this back together and actually have the impact through the combination of wearable devices and digital twins. The last thing I just wanted to highlight is this cross-pollination. I'm sure we're going to have a lot of it here today and tomorrow, but I'll call out Professor Mike Hahn, some in the audience somewhere, raise your hand, don't be shy. Oregon professor, does really cool work. One of my PhD students found out what he was doing, reached right out to Professor Hahn, and they had a conversation. Mike used to work with an ankle and foot surgeon who was at Oregon, recently moved to Vanderbilt. Mike connected us with him. This was one of the stakeholders that we interviewed as we were working on developing this ankle exosuit to help reduce Achilles tendon strain during the rehab process. So lots of different interconnections, and I think, again, this is the strength of the Alliance. This is what you all are a part of. This is what we're bringing together as a group. So the societal impact, I think, really hinges on us overcoming these barriers together. I'm just do a really quick sneak peek if anybody wants to learn more about the ankle exosuit that we're working on. This is the original device we developed a few years ago for walking. It's device that's intended to reduce the strain on the Achilles tendon during walking. We're now adapting that to work for runners and other athletes, again, with an eye towards helping with the recovery process or helping to reduce injury risk. I don't have a prototype I'm ready to share publicly yet, but we've been working really hard through user-centric iterative development to get a lightweight device. It's currently under 500 grams. It offloads about 10% of the Achilles tendon force during running. And we've got a few other things to work out, but we're trying to get to the point where this is practical, wearable, and useful over a long period of time. So with that, I'll wrap up with the final takeaways. Thanks for the support from the Alliance and acknowledging the lab members at Vanderbilt who have been conducting this work. Thanks.